Hey guys, what's up? So today we're going to be looking at the triangular prism or wedge, and the volume of the prism, the triangular prism, V is equal to A times L, where L is the length of the prism, which is actually over here. Let's look at the diagram. The length is from here to here, right? So L is the length of the prism, guys. That's what L is. And let's look at A now. A is equal to the area of the triangle, the area of this triangle ABC here. And if we can look here as well, we see that many times we're given the height of the triangle, right? And we already know from triangles that the area of a triangle is equal to half base, which is B here, the base multiplied by the height. But if we're not given the height in the diagram, guys, then we have to use Heron's formula, which is the square root of s times s minus a times s minus b times s minus c. Cool? But many times you're going to be given h, but we're going to do some examples where you have to find Heron's formula and then multiply it by the length to find the volume of the prism. All right, guys? So we also see here it says where A, B, C, H, and S are the dimensions defined as in a triangle. So A, B, C, B is always the base, H is always the height, and A and C are the other two sides of the triangle. Cool? And S is a semi-perimeter for the triangle. So S is actually equal to the length of A plus B plus C divided by 2. All right? So guys, there are many times in life when you're going to see this wedge, and I'm going to use a very good example, okay? Let's draw a little wedge here. And there are many times in life when you're going to use these, okay? And the one main time you're going to use this wedge, okay, or this triangular prism is when you need to hold a door open, okay, guys? Like many times you want to keep the door open, right? And in order to keep this door open in your house or wherever you are, the door keeps slamming or the wind keeps just hitting this door down. So in order to keep the door um, open, right, you just put a wedge against the door, okay? And when you put this wedge against the door, you no longer have to worry about the door swinging and slamming and everything. And most people have a wedge in their home, okay, that they use for this purpose only. And the wedge is used very commonly in engineering. So for those who want to become engineers, get used to these shapes, guys. You know, really embody it. And as I said, try to enjoy the process of learning this, learning the mathematics. Cool. And if you do physics as well, you're gonna use this very, very often. The wedge. It's actually known as a simple machine in physics. It's one of the simple machines that we use in daily life. Okay. So let's move on. Let's look at 3 examples as usual. All right, guys. So we're going to look at some examples of finding the volume of a triangular prism or a wedge, okay? But we also need to look at the total surface area for a wedge as well, okay, guys? And in this case, it says the total surface area of the wedge is equal to 2 times the area of the triangle plus the rectangular top plus the rectangular base plus the rectangular back. All right. And let's just look at that. Let's just look at this triangular prism here to see what that means. So if we look at the total surface area, we see that there are 2 triangles, one here, right? One here and the second one here. So that would represent the two areas of the triangles. Then it says the rectangular top, which would be the face we're looking at here. So that's one here, that rectangular top we'll look at. Then the rectangular base, which would be down here, the base of the prism. And then the rectangular back, which would be this side here around the back, right? So clearly that's equal to the total surface area. And we also may be asked to find the total surface area of a prism as well, okay? So what we're going to do for the examples now is we're going to find the total surface area and the volume for 3 examples, okay? So for the first one here, we know that the volume is equal to the area multiplied by the length, cool? And in this case, we need to find the area, okay? Because we need the area to multiply it by the length, which in this case, the length is 10 centimeters. And to find the area, we can use half base times height for the triangle, because luckily we have the perpendicular height in this example, okay? So the area is equal to half base times height. All right, guys, so a half base times height, in this case, the base is 5 centimeters, right? So a half base times height would actually be a half of 5 centimeters times the height, the perpendicular height, which is 4 centimeters, right? So for the area, guys, we should actually end up with 10 centimeters squared, right? 2 can go into the 4 2 times, which would give us 10 centimeters squared. So to find the volume now, it would actually be the area of the triangle, which is 10 centimeters squared, multiplied by the length, which is 10 centimeters in this example, and the volume should be equal to 100 centimeters cubed. Cool? All right, so we found the volume. Let's just put a V here. And now we need to find the total surface area. Okay, guys? So the total surface area is equal to 2 times the area of the triangle, and we already found the area of the triangle. It's 10 centimeters squared, plus the rectangular top, okay? And the rectangular top is this face here. And if we can see properly, this rectangular top here is what we want. Cool? We want that area right here. So let's find it, okay? We can see that for the rectangle, it's actually 4 times 10, right? 4 centimeters times 10 centimeters. That's actually the area. Then we need the area of the rectangular base, which is down here, right? And that's actually 5 centimeters times 10 centimeters. Then we need the area of the back, which is this here, right? Which is actually 3 centimeters times 10 centimeters, right? Okay, so we should end up with, this should actually give us 20 centimeters, right? Plus 4 times 10 would give us 40 centimeters. This is all in centimeters squared because they're areas. Plus 50 centimeters, right? Let me just put an equal. Plus 30 centimeters squared, right? So when we find the total of all of these now, 50 plus 40 would give us 90, 90 plus 20 would give us 110, and 110 plus 30 would give us 140. So the total surface area is actually 140 centimeters squared for the triangular prism or the wedge, right? All right, guys, so we did the first example, and it was pretty easy, not too difficult to understand. And let's do another example. Let's do an example now, guys, where we don't have the perpendicular height. So let's dive right into another example, okay? All right, guys, so we're looking at this second example here. And in this second example, guys, we don't have the perpendicular height, okay? But we're still asked to find the volume and the total surface area, okay? So for the volume, we already know that the volume is equal to A multiplied by L, okay, where A is equal to the area of the triangle, right? But in this case, we don't have the perpendicular height, okay? We don't have the height here. So if we don't have the height, then we need to use Heron's formula. All right, guys, we're going to have to use Heron's formula in order to find the area of the triangle. Right, so this would be equal to the square root of S times S minus A times S minus B times s minus c, right? And s is equal to a plus b plus c. So in this case, a is 3, the base is 4, and c is 5, right? So we're going to have 3 plus 4 plus 5, and this should all be in meters, divided by 2, and that would give us s. So 3 plus 4 plus 5 would actually be 12 over 2, which would be 6 meters, right? So for the area, it's equal to the square root of 6 multiplied by 6 minus 3, right, times 6 minus 4, which is the base, times 6 minus 5, which is c, right, the third side of the triangle. So a in this case is actually going to be the square root of 6 times 3 times 2 times 1. And 6 times 3 is 18. 18 times 2 is actually 36. So it's a square root of 36. And in this case, the area for the triangle is equal to 6 meters squared. All right, guys. So we can easily find the volume now. The volume is equal to 6 meters squared multiplied by the length. And in this case, the length is 12 meters. So the volume is going to be equal to 6 times 12, which is 72 meters cubed, right? Cool. So in this case, guys, we did not need the perpendicular height. And the reason why we didn't need the perpendicular height is because we already used Heron's formula to solve the question. So don't get confused when you don't get the height, guys. Continue to solve the question using Heron's formula. Okay. So now we need to find the total surface area. And we already found the area for one triangle. So we know the total surface area for the prism is 2 times the area of the triangle, the area of the two triangles. So it would be 2 times 6 meters squared plus the rectangular top, which is this face here that we're looking at. So that would be 5 meters times 12 meters plus the rectangular back, which is actually the back here, right, around this side. And that's actually 3 by 12, 3 meters by 12 meters. And the rectangular base, which in this case is here, and that should be 4 meters multiplied by 12 meters. Cool. So let's actually just multiply all of these. 2 times 6 would give us 12 meters squared, plus 5 times 12 would give us 60 meters squared, plus 3 times 12 would give us 36 meters squared, plus 4 times 12, which would give us 48 meters squared. Cool. So when we add all of those now, the total surface area is actually equal to, right, the total surface area is actually equal to 102 meters squared. All right, guys. And remember, you can use remember you can use your calculator. All right, guys. Remember that you can use your calculator. So just add 12 to 60 to 36 to 48, and you should get, whoa. All right, guys. So if you add all of these with your calculator, you should get the total surface area being equal to 156 meters squared. All right, guys. So great. So we found the volume and we found the total surface area. And great. We're pretty much good here, guys. All we need to know is one example to kind of really solidify this in our brains, right? So let's do one more example, guys. All right, guys. So let's look at this example here. And we have a triangular prism. And the triangular prism is actually at a 90-degree angle, okay? Which is very interesting. So we're asked to find the volume and the total surface area of this example. So let's do that, okay? The volume is equal to the area multiplied by the length, right? And to find the area, it's pretty easy in this case because 4 is actually the perpendicular height because it's a right angle triangle. And we can find half base times height, which in this case the base is 2 millimeters, sorry. So this should be equal to a half of 2 millimeters multiplied by 4 millimeters. So we should actually end up with 4 millimeters squared for the area here. And the volume should be equal to 4 millimeters squared multiplied by the length, which in this case is 8 millimeters. And we should end up with 32 millimeters cubed. All right, cool. So pretty simple, guys, pretty simple. Now let's find the total surface area, and this should be equal to 2 times the volume of 2 times the area of the triangle, which is 4 millimeters squared. Then we need the area of the top, okay, which in this case the top should be the face we're looking at right here, this area here, that square, right? And that would actually be 5 millimeters times 8 millimeters, right? Then we need the back, which is this side here, and that would actually be 4 millimeters by 8 millimeters. And then we need the base, which is this down here, and it would be 2 millimeters by 8 millimeters, right? So for this, we should actually get 4 times 2, sorry, should be no 4 there. We should actually get 4 times 2, which is 8 millimeters squared, plus 8 fours, 8 fives, actually 40 millimeters squared, plus 8 times 4 is actually 32 millimeters squared, plus 16 millimeters squared. And when we add this in our calculators, guys, we should actually get the total surface area being 96 millimeters squared. All right, guys, cool. So finished 3 examples now, guys. We really should understand this now. We really should not have any problems with this. And guys, it was wonderful. As I said, always try to enjoy the math. Enjoy the mathematics. And I'll see you in the next lecture. All right, guys. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.